Good evening. I just want to welcome everyone to the EastGen Extravaganza. My name is Scott Cornish. I'm a regional sales manager at EastGen. I do also some beef work with EastGen, and just was asked to give a presentation tonight on beef and dairy genomics. I just want to keep this simple. I think sometimes people get a bit confused or intimidated by the word genomics and what it actually is. I just want to cover probably three main things tonight, and that is, what is genomics? How does it work? And I'll spend some more time on how you can use it to advance your herd. Some of the things we'll talk about tonight, because this is beef and dairy, some of the terminology will kind of cross-pollinate. So I'll try to be clear on that. And if there is questions, we'll get to them at the end. Genomics is the study of a genome. I think we get confused a little bit. We talk about genomic bulls or genomic females. They're still the same females they were. Genomics is just a way of identifying those ones that are superior at an earlier age. I think what we really want to talk about is genomic selection. This is the use of DNA information to form a genetic evaluation or selection program. So I think that's what we want to talk about more, is how we use genomics. We don't need to know exactly what it is. That's for the scientists to interpret and use that data. We just need to take that DNA information and make decisions or make selection programs that fit our needs. The DNA information comes in thousands of markers, so it's very complicated. I think we just need to use that information and use the people that work with it all the time to help ourselves in both making genetic predictions more accurate and making better decisions on farm. I just want to talk a bit about the traditional ways of making genetic improvement. Hopefully this is a review for some, but I know on the beef and dairy side there are a little bit of differences. I'll just show an EPD graph here. Is the traditional beef way of making a genetic prediction. As we can see on here, what I really want to point out is accuracies at 91%. Those are getting very accurate. With this bull here, his genetic evaluation has come through some progeny proving system. So this bull is actually starting to get more accurate information. And we'll talk about accuracies and reliabilities. Accuracies we usually associate with beef cattle, reliabilities we associate with dairy cattle. Again, here's an example of a Holstein bull proof evaluation. Again, we see a reliability here of 78%. That tells us that it's starting to get accurate. So what we want to talk about is, when we initially start with an animal, they have little information. When we start with your 4-H calf, that calf, we probably know the parentage, we probably know the sire and the dam, and we can start to evaluate what that animal's genetic potential is at that time, but with very low accuracy. So those accuracies might be in the dairy situation 30%, maybe in the beef situation less than that, or you might see a PE, which is pedigree estimate. So very little reliability just with sire and dam. But with that, we can start to build more genetic information. And as that sire and dam have more information, we can start to get the genetic evaluation more accurate. If the bull has known parentage, or this can be for a cow too, as information of this bull's offspring are recorded with breed associations, the accuracy and reliability increases. So as a bull has 10, 20, 40 offspring, that reliability gets higher. And traditionally, that's what we have done. In the dairy world, we used to have what we would call test bulls. Those bulls would get sampled in breeders' herds, and that information would come back and be recorded by the breed associations to get a genome or a genetic evaluation on them. More progeny equals more reliability, and that genetic evaluation is more accurate. So again, here just the example is parentage only. This is beef or dairy. If you only know the dam and the sire, there's low accuracy. There is some prediction, but it doesn't mean that we really truly know what that animal can do. Parentage plus a small number of offspring, it gives you higher accuracy. You know, if a cow has 5, 10 calves, then we start to increase that accuracy. Same on both the beef and dairy side here. If we have known parentage and a large number of offspring, we get higher accuracy and up into the 80-85%, and that's what we've traditionally done. The only thing is this takes time. When we have bulls or dams, we need a significant number of offspring to make that information accurate. So in some cases, a bull might need to be 5 years old before we got to that 80% accuracy, where we could really truly say in the beef world that a birth weight EPD of 5 was actually going to be 5, without that maybe going up or down some significant amount. Very same with the dairy proof. If a dairy bull's milk number was 1500 with just parentage only, we would probably expect that could change over time as we get higher or more percentage of offspring. That accuracy gets higher. So if we see a bull that's say 1500 kilograms of milk, the chances are that he passes that on once we get to that larger number of offspring. So that's the point I want to make in this presentation, and what genomics is about is making those accuracies and reliabilities more accurate at an early age. So I'll get into why we use genomics and how we use it. By simply DNA testing animals, preferably at an early age, we can increase that reliability and accuracy of that animal's genetic potential information very early. So whereas before we had to wait until there was a significant number of offspring, which took 3, 4, 5 years, we can now do that at an early age. So through DNA testing, we can compare that to previous animals that we've recorded information on for a number of years. Admittedly, the Holstein breeds are well ahead of the beef breeds on the amount of information that's recorded. But through comparing the DNA information with that recorded information, we can accurately predict at a very early age what that animal's genetic potential is. DNA testing is very easy. The most popular ways right now is a tissue sample. EastGen has an Elevate program that is a tissue sample, just a quick ear puncture will give you that information. Hair samples, semen samples, blood samples. It is very easy now, and the cost has been quite reduced in recent years. By adding this DNA information to traditional parent averages, so that's when I mentioned we have just your 4-H calf that we knew what his sire was or we knew what her dam was, we can make better decisions on how to proceed with that animal at an early age. Just want to use this example here where we can have 3 full sisters, whether they be flush mates, they be full sisters. I mean, of course, they'd be different ages, but we really can't predict what they will transmit in terms of a genetic package. So through DNA, we can sample these 3 heifers, even their full sisters, maybe they're flush mates. I really don't know, but it can identify the ones that are genetically superior. So whether heifer A or heifer B is higher in a milk number or a conformation number, we can identify that now at this early age, and that helps us to make better decisions with those animals at that time. So we'll use that example before with those 3 females. When that DNA information comes back and we know what they are genetically capable of, we can select sires to breed those females to that makes a better decision. Before, with just parent average, we would have probably picked one bull because it would have been the bull that would complement the sire and dam the best. Now we can identify those heifers that maybe need a different sire that we would not have used before. We can also use it to cull heifer calves at an early age. Dairy farmers are realizing this recently with the value of fresh heifers not quite what it was at some points. Some herds choose to use this genetic information to sort their females at a very early age, so they don't have to raise them to a point where they need to sell them as 2-year-olds. We can also identify superior animals within a herd from which replacements should be made. So, you know, a herd that's milking, or even a beef herd that has a number of cows, we can identify those females that we need to be raising replacements from. There's a few other things that I think people have started to use more and more. We can identify high immune responders. This is both in the beef and dairy world, mostly the dairy world right now. Beef cattle, it will be coming. We can identify those females that better respond to vaccines and are healthier. We can also identify homozygous polled females or bulls. We can identify A2, A2. So those herds that are trying to breed for a specific program or a specific marketing avenue can use genomic testing to identify the animals that they want to work with. So just want to review, this is a beef and dairy presentation. I'll just talk a bit about beef for the minute here right now. You can identify superior animals. It helps you make accurate breeding decisions at early ages. Again, we can identify higher immune responders. Homozygous polled has been a buzzword in the beef world for some time. It's a way to identify that early, and where traditionally we would have to wait till a number of calves were born before we knew if the bull would be homozygous polled. Hair and coat color is another thing that in the beef world is very important, and we can identify that early. The next thing I want to, and maybe this sets it apart a bit from dairy cattle, is predict feeding and marketing options for individuals. So this means if we can DNA test a calf that's young, we can predict where that animal should go in terms of marketing into a specific feeding program, whether that animal's higher marbling, higher fat, lower fat, all those kinds of things, we can start to identify that early and put those calves into the correct marketing options. As well as on a purebred side, we can identify those polled or homozygous black or a bunch of different things at an early age and market them in the way that makes the most sense for the producer. Just want to also talk a bit about if we get to the point where why should we record actual data on farm? And I think everyone needs to realize that that's still very important. Even with pedigree information, progeny information, plus genomic data, we're not going to get to 100% accuracy. So it is still very important to record information on farm. We have to keep in mind that this is only part of the equation. We're talking about genomics and proven animals. That's only part of the equation. There's also that management part of breeding cattle that's very important, and only through on-farm information can we accurately analyze that. On-farm recording is very key to managing superior genetics. So I do think it's very important that we still use, things like in the beef side of things, bio, DHI on the dairy side of things. It's still important to classify cattle, and that helps to validate genomic information as well. That's what this DNA samples are compared to. So it's very important that going forward we continue to collect that on-farm data to validate some of this genomic information. So just to review, genomic selection is the use of DNA information to form a genetic evaluation or selection program. This allows us to predict the genetic breeding potential of an animal at an early age. It helps producers to make accurate breeding and management marketing decisions. So the whole point that I want to drive forward here is just the fact that through genomics we're allowed, or it lets us make more accurate decisions at early ages. We can shorten that generation interval and use the genetics from the animals that we really need to work with at an earlier time. I think we've always had great proving programs before, both in beef and dairy, but by the use of genomics, it's just allowing us to do that at an earlier age, and it allows us to be more profitable as farmers. We can identify those animals we want to work with or need to work with without spending that time finding out which ones we need to work with. Hope that makes sense to everyone. Looking forward to the questions that might arise. I guess I want to clarify that genomics is a great tool in the future. It will help producers be more profitable, be more relevant in their respective industries, both beef and dairy, as we go forward. And yeah, I welcome any questions, and hopefully this was useful to you folks, and thank you for being part of the East Gen Extravaganza.